All right, class. Welcome to an episode of Brand Academy. Okay, my name is Bran. Let me click here to see my face here. So my name is Bran. I'm actually Mr. Wynn's twin brother. As you guys can tell, we look very similar. We're both two very beautiful looking people. And so he actually asked me to help him teach you guys the next section our of our chapter, which is chapter 1.8, and we are on area of polygons. Okay, so anything I write here on the screen, please be sure to write it down in your notes as well. And so we're actually going to start right now. And so let me get rid of my beautiful face. Right. Okay, so chapter 1.8, areas of polygons. And specifically speaking, we're going to be talking about regular polygons. Okay, so this might be review for most of you guys. This was taught in geometry. In terms of regular polygons, right, the word regular would indicate that the polygon has all sides to be congruent and then all angles to be congruent. Okay, we're going to draw a little diagram for you guys here. So let's draw a hexagon. Okay, so I'm drawing a regular hexagon. So it might not look regular, but I will put these tick marks here, right, to show that it is a regular hexagon. And of course, not only are all the sides congruent, all the angles are congruent as well. Okay. And so our problem here specifically, we're going to be talking about finding the area of a polygon. And so for right here, problem 1, we're given a regular pentagon with sides equaling 8 meters. Okay, and our goal is to find the area. Okay, so what we're gonna do here, we're actually gonna break this down a bit to solve it as easily as we can. Okay, so we know all the sides are 8 meters, so I'm just gonna draw right in here 8 meters, and since one of the sides is 8 meters, then all of the sides will be 8 meters, right, since all the sides are congruent, since it is a regular pentagon. And so right now I want you guys to draw put a point at the center of that pentagon there. And what we're actually going to do, we're going to break this pentagon into 5 triangles, okay? And so the way we're going to do this is from the point here, we're going to connect it to all of the vertices. Okay, and again, vertices is just a fancy word for a corner. Okay, so let's create your 5 triangles here. Okay, so technically speaking, since this is a regular pentagon, all 5 of these triangles that we just drew are congruent to each other. Okay, so really our goal, all we have to do really is find the area of one triangle, then so again, sorry, after we find the area of one triangle, we then just multiply it by 5. right, to find the whole area of the polygon. So just looking at our 5 triangles here, okay, I want to talk about this central angle. Okay, so this central angle of a polygon is 360 degrees, right, indicated by this full circle here. And so my question is, what is the angle of all these individual triangles here, right? So that angle in blue, to find that angle, we're going to take 360 divided by the number of triangles we have. So we have 5 triangles. So we divide it by 5. So each of those angles are actually going to be 72 degrees. So this right here is 72 degrees. 72. And so now what we're going to do next is to find the area of this triangle here, right? So recalling back, right back in like 4th grade, the area of a triangle equals 1/2 its base times its height. Okay. So right now I'm gonna draw the height in. Let's make it like purple. Okay, I'm gonna draw the height there. So my question is, how can we find this height? Right, using the angle we have right here, this is 72 degrees. And so, since this is actually an isosceles triangle, right, since we know that it has to be congruent, since it's a regular pentagon, so both of these sides right here are congruent to each other. All right, so then here we're going to know that our height actually bisects that 72-degree angle, which would make these two 36 degrees each. And also, this height also bisects the sides here, so each of these should be 4 meters. Right. And it also ends up being that the altitude of this triangle forms that right angle. So now, since we have a right triangle, we can use our trig ratios, our sine, cosine, and tangent, to find our height. So the trig ratio we're going to use here, we actually have an opposite, and then we're going to use the height as our adjacent. So we're actually going to use tangent 36 equals our opposite, which is 4, over our height. And our height should equal 4 over tangent 36, which ends up being about 5.5. Okay, so this is our height, okay, that we can plug into here. And our base, right, which we already solved for, or not solved for, our base was given to us actually. Our base is 8 meters. And our height is 5.5 meters. And so multiplying this out, our area would equal 22.0. Squeeze it in right there. And so is this the area of a polygon? No, it is not, right? This is just the area of this one triangle. So to find the total area of the polygon, down here I'm going to take the area of the triangle, 22.0 times 5. And the reason why we times it by 5 is because there are 5 triangles. So the total area of our regular pentagon should be about 110 meters squared. And that is our answer. Okay. So example 2 right here, I'm actually have you guys do it on your own. And so this is right on the side here, this is a regular decagon with, let's say, with sides 11 centimeters. Okay, so each side is 11 centimeters. So please pause the video right here, and when you guys are ready, I will show you guys the solution. Okay. All right, so here is your solution. So feel free to pause the video here to see the steps properly. All right, so that is it for the lesson on chapter 1.8. Good luck on finishing the homework in the back of this worksheet. And also, just as a side note, Mr. Nguyen wanted to let you get, or to let Lulu, Jenna, and Gabby know that you guys will be making up your quiz tomorrow as a team, okay? So you three will be making up your quiz on Wednesday during class, okay? Other than that, chúc mừng năm mới and have a great rest of your day, okay? Bye, guys.